coming. My name is James Borthwick. I'm a software developer at PDFTron Systems. We are a leading provider of PDF and document processing technologies. We're based in Vancouver, Canada. And today I am very excited to be here to announce PDFJS, which is our latest product. And PDFJS is a complete browser-side PDF toolkit. And it can do everything you would expect you would want to do with PDF using the browser, without using a server, meaning rendering, annotating, form filling, word splitting, anything you want to do. So today's presentation is sort of why we wanted to do this and how we got there. So software is eating the world. This is a pretty well-known quote, and I'm sure I'm not the first person to extend that to the web using software. Meaning more and more of what we're doing with software, interacting it via a web interface. And probably most of you don't need much convincing of that, but just as a visual example, these are the top, these are the top 16 tags or topics on Stack Overflow. And the ones that I've done in the red boxes are ones either directly web technologies or are frequently used server-side to support websites. So if more and more of our time interacting with software is actually interacting with a web version of software, we have to ask ourselves, where does PDF fit in this new world? How do we interact with PDF? And currently there's sort of two use cases. So this is what we're going to talk about in this presentation, is how we do that today, how web deals with PDF, and then can we do any better than how we're currently doing, and then finally PDFNet.js and what it brings to the web world. So how does PDF fit into the web? The first sort of like standard use case here is you download it. There's a button, download PDF, it goes to your hard drive, and you can save it later for archival purposes or for your record. I think it's a perfectly valid use case, and it's something that we will continue to want to do. But it's not really the topic of this conversation or this presentation, which is when you want the app to actually present the PDF to allow the user to view it within the app, to interact with it in some manner, or to actually do something with the PDF in that app. So if you're doing it in the web, you need to then do something with it using web technologies. So typically when the user wants to do this within a web app, the PDF will be converted to some sort of web-compatible technology, meaning a technology that the browser naturally knows how to deal with and to render. So it's converted to PNG, HTML, SVG, one of these formats. And these are solutions that we at PDFTron have been offering our customers for years. And for some use cases, they are acceptable for what the app wishes to achieve. But they all suffer from a drawback, which is they all require this conversion, the server conversion. You know, when you do something with the PDF, the user has to upload it to the server, and the server has to convert it to some other format, which obviously takes time and costs money, because the more and more you're doing this, you need to have more servers processing more and more PDFs, which is the scaling problem. So server-based conversion is a bit of a crutch that we're using right now, because PDFs can't deal with, or the web browsers can't deal with PDF. So can we do better? We ask ourselves, is there something we can do better? Because all our customers are using this, we weren't fully satisfied with this as an end solution. So is there a way we can make PDF a first-class web citizen? Meaning, is there a way we can make browsers natively, if you will, understand and display PDF without the assistance of a server? So that was our main requirement. We wanted to process PDFs in browser with no server-side dependencies. So when we looked to do this, okay, how can we do this? And the sort of thing that really jumped out as the obvious solution was to use the new HTML5 canvas element. It's used by the PDF.js project that you may have heard of as a sort of back-end rendering engine. And so we looked at this and thought, okay, this is maybe something that we can build upon. to create an in-browser PDF solution. So for those of you who aren't familiar with Canvas, I'll just briefly describe what it is and how it works and how you can use it to show PDFs. So this is from the Firefox documentation Canvas API. The Canvas is an HTML5 element that can be used to draw graphics using JavaScript. So as an example, they say you can use it to draw graphs or photos, create animations, do processing, or rendering. So the question for us is, okay, can we use this to render PDFs? So how would you use it to render PDFs? And how this works is you would have a JavaScript program that can understand PDF file format. This, for example, is a PDF snippet that draws a red circle. And what you would then need to do is have it translated, if you will, to the equivalent in Canvas. So this is a Canvas snippet that draws a red circle. And the PDF, would then, the Canvas when it gets this command shows a red circle. So on the left is what it would look like when you look at it in the PDF browser, and on the right is what it would look like when you look at it in Canvas. So you would build on this. You would make your JavaScript program not only be able to understand red circles, but everything that PDF can contain. Different colored circles, different shapes, text, images, etc., finding the Canvas equivalent for the PDF representation. So we thought, okay, I mean, this looks like something we can use. But the more we dug into it and the more we looked at it, the more problems we were finding. And so I'll just outline a bit on what we found and why eventually we decided Canvas was not really the answer. One immediate irritant was that all the Canvas rendering is done in the UI thread, meaning if you give it too long to render, you're going to end up with these pop-ups on the web saying that it's running too long, you want to close the tab, there's issues with this. So that does not give a very good UI experience. The second is that Canvas is hardware accelerated, which at first sounds nice, but then you realize that it's actually relying on graphics drivers from computers that ship with the graphics cards, and those can often be buggy, and meaning that the Canvas is going to do different things on different systems depending on what the drivers are. If you go and you look at the Chromium web forums on this, you'll have people complaining about it doing strange things, and the Chromium developers' common sale is bugging your graphics driver, restart your computer, and update your drivers, and this obviously is problematic when you are trying to create a reliable PDF renderer. Lastly, Canvas and PDF have incompatible graphics models, meaning there's a certain items or certain things that PDF can do and can understand and can represent within the PDF file, and there's another set that Canvas can understand and do. And there's a lot of overlap, but it is not an exact match. And so if you have a PDF that sits outside of Canvas, you run into trouble. And this is actually even a little bit worse than this, because when you look at all the different implementations of the Canvas element for the different browsers, they all do it slightly differently, and they're a bit inconsistent, and they don't all implement the same things, or they have different random custom extensions. So you end up in this bit of this either lowest common denominator or quagmire, trying to jam PDF and fit it into something, different things that really don't fit. And so, like the red circle, I'll give you something that doesn't work with Canvas. And on the left here, you have a text snippet of some text in PDF that is filled with a gradient. And the text and the gradient both have different transforms on them. And in Canvas, you can't do this. They both must have the same transform. So how can you represent this in Canvas when your program goes and tries to find the Canvas equivalent? So this is the page it came from. It's actually a page from the PDF specification. That red arrow is pointing at the text I showed you on the left. And then when you try to render this using PDFTron.js, which uses the Canvas element, this is its output. And in this case, the text is just missing. And you can see that there have been other problems created on this page as well, which is troubling to say the least. And when you see this sort of thing, you really have to ask yourself, and this was talked about a bit at that panel, is what makes a PDF viewer a PDF viewer. And really, primary value proposition in PDF is that it looks the same everywhere. When I look at a PDF on my screen and I send it to you, I can be confident that you're going to see the exact same thing as I saw. There's an article online on the PDF Association's website that was put up not too long ago. I think it puts it well. It's talking about PDF. It says it's about a completely reliable experience, and that the format's core value is based on its ability to reliably represent the document author's intent in all respects. And the more we looked at it, the more we saw that we just weren't going to be able to achieve this using Canvas. So we didn't think that our customers would find this acceptable, and it certainly wasn't acceptable to us. So back to our requirements, something that we really now needed to be very aware of, is we wanted to create something with absolutely correct rendering. So how can we do this? We want to render PDF in the browser. We want to have no server-side dependencies for all this, and we need to have absolute correct rendering. So what we thought, what we found when we looked at this, is that the answer to this didn't rely on the latest and greatest web technology. It was actually the answer was old. When you look at how reliable desktop renderers render PDFs, they don't rely on system-level graphics libraries to do it. They're not using DirecTV or GDI. They're not using core graphics like Preview on Mac. They do it themselves. They do everything internally. This way they can guarantee that the PDF specification in its entirety is covered. They're not leaning on buggy graphics drivers. They can offer absolute control and absolute reliability in the PDF rendering. So is this possible to do in browser? Can we create a PDF rendering engine that runs entirely in browser? And the answer is yes, you can, and it's exactly what we've done with PDF.js. PDFNet.js processes the PDF completely in browser, entirely server-side, entirely client-side without any server component, and gives you the correct rendering. And then beyond rendering, which is really awesome, is this complete PDF toolkit. Meaning it does far more than just rendering. You can do annotating, you can fill out forms, you can generate PDFs, split, merge, reorder, organize pages, redact, extract text, convert PDF, PDFA conversion, validation, encryption, decryption, optimization, linearization. Pretty much anything you would want to do with a PDF, you can now do entirely client-side. So the fact that there's no server is really important, and it takes a little while for this to sink in what the ramifications of this are. So what it really means is that without the server component, apps are easier to develop, they're more responsive for the end user, they're more reliable, and they're more scalable. So I'll go over the reasons for this. One, they're easier to develop is there's no need to set up a server stack, at least as far as their PDF processing is concerned. You don't need to worry about figuring out how all the server stuff works and getting the servers to do it. You do it all client side. When you're developing the app, the programmer can keep the entire sort of model of how this is working right in front of them on the client. They don't need to spread this application logic between the client and server back and forth, as well as do this asynchronous client-server communication, which is always a nuisance. It's easier to have bugs crop up in this. When they do crop up, they're harder to reproduce, which means they're harder to fix. If it's all client-side, it's just far easier to reason about, which makes your developers faster and more effective. And then lastly, of course, because we're not converting to these other file formats, we avoid caching. And caching is always considered one of the hard problems in computer science. So in this case, with my PDF partially rendered, is it waiting in some, or partially converted, or is it waiting in some conversion queue, or did the person delete the original PDF, so now I can delete the cached version, or rename it, et cetera, et cetera. You just avoid all those caching hassles. Secondly, apps are more responsive. If you're dealing with local files, there's now no reason at all for the PDF to even hit the server. It can deal with it entirely in the app. You just open it, goes into memory, does everything right there. Cloud files can also, if you're dealing with a cloud file and you want to save it back to your computer, you don't have to re-download it like you do with other solutions where, because you don't really have the PDF in your browser, you just have an image or some other file format. Every time you need to do something with the PDF, it's going back and forth. Apps are more reliable because if you have some sort of problem with your PDF processing logic, if it's on a server, that means one user's problem or one thing crops up, all of a sudden the server's coming down, some poor engineer is getting a page at 3 a.m. to go fix it, all your users are frozen over their software. It's all done client side. It means all these instances are naturally isolated from each other. So if there's some crazy edge case, it's only going to affect that one user and the rest of the system will continue to run uninterrupted. And it's also more secure. PDFs are essentially user input, so if you can avoid processing them server side, then you avoid just one more vector for someone to insert something into your system that's undesirable. And then on the flip side of this, as far as security is concerned, if you're a user and you're worried about sensitive PDF documents, they now no longer have to go to the server. They're actually dealt with entirely on your computer. Lastly is scalability. PDF processing, rendering is not often it can be quite CPU intensive. So the more and more, the bigger your application gets, the more users you have, the more PDFs you use. If you use servers, you end up having to scale all of these with them, and that becomes expensive and time-consuming to maintain. PDFNet.js is essentially a scalable plugin model where you can have millions and millions or billions of concurrent users, and because every user brings with them a computer that does the processing, then the scaling with PDFNet.js is essentially free and infinite. So apps are easier to develop, they're more responsive, more reliable, and more scalable. So I'll just show you a couple of quick demos of this. So the first thing I'll do is just opening the PDF. So we'll open a PDF here. It shows up, it just looks like a normal viewer. We can annotate it. And these are all happening like right on the, my screen recording software slows it down a bit, but it's all happening right on the PDF. So when you want to save it, there's no, oh server, can you please merge in these annotations? You can just save it. It happens instantly. It does have to quote unquote download it because it's still sandboxed. And then you can see this showed up in my. It's opened, in the PDF viewer here. So another demo I'll show you that shows the sort of the power of doing it all locally is here. You can see the size of these files. I can take a number of PDFs here, including a couple that are about 20 megabytes. I'm going to merge them. So it opens up these. I can change the order or whatever. I decide that this is the order I want to merge them in. I can just save it right back. Merge, download. There it is. And then you have the file. It's all these files merged together. We've also added some script handling for more complicated, interesting PDFs. Here's an example of a PDF that's implements a calculator through JavaScript. So you can see that this continues to work. So of course this is more often used in forms rather than actually implementing calculators. I think this is more someone having a fun with PDF. But there are serious, of course, uses for this. Here's an order form. And so it works where they have all these different things people can order, and then you can fill out this form and you can fill in different quantities. And you can see these are now being processed and filled out. And when you're happy with it, address. Yeah, I should also say this is it's doing a bit of a data validation, so that if I try to type letters in this quantity field, you can hear me. Anyways, it's not doing it, but as soon as I enter a number, it pops up. And again, I want to see that one and go straight to my, this one, my downloads folder. And then if I were to send it to someone else, they open it with whatever reader they want. And all the data is there. So, one last demo I'll show is, and this sort of illustrates one more problem with Canvas I didn't mention before. I will open a document with a lot of paths in it. This is a map. I'll zoom in on a section. Screen recording software which I have not used before. Seems to be spinning up the fans. Okay, we'll come back to this. This thing. Sorry, just bear with me a second. So I zoom in close. You can see that it's continuing to render as I get closer and closer, which is, I guess, doesn't seem that fancy because it's what you'd expect a PDF renderer to do. But in Canvas, there's certain memory limitations, and so the PDFJS project, they just cap the canvas at a certain size. And here, so this is it at 200%, 270%. When you get closer, it doesn't really matter how close you get because they cap it at a certain size. It will never re-render, it will never come through clear. It will always stay like this, just sort of like blowing up an image, which really is not what you expect a PDF to do. So this will continue to render.
Question?
Yep.
Sorry to interrupt, but you said you're not using Canvas, but obviously you're drawing.
Yes.
So what is it that you're drawing through?
It's rendering everything internally, creating an image, and then just transferring that data to Canvas as an image. So it's not really using any of the Canvas commands other than here's like bitmap data.
Okay, which might be hardware accelerated. It might have, might have issues, jankiness or whatever, but it's a bitmap that you've rendered purely in JavaScript.
It's a bitmap. I mean, it should be just like
I
this
understand.
pixel is this.
All the way
this
down to
pixel
the
is
pixel you've rendered
Yeah.
it. Okay,
Yeah.
thank you.
Yeah. So those are the demos. Just briefly, code snippets. How easy is this to work with if I actually want to put it into my app? The first reviewing, of course, this couldn't be simpler. It's just create our PDF web or aim it, add a PDF, and then it shows. And this gives you basically the PDF URLs are showing you what you can set, different page views and zoom in and out and annotate, etc. And then if you want to customize this in any way, by adding or restricting functionality or changing the look and feel for your particular app, then it's just a matter of building on top of that. This, you don't have to look at every line of code. This is just to show sort of like, I guess, the complexity level we're doing things with PDFNet.js. This would be from merging two PDFs, and it's essentially the same as it would be in a native app in any of our native SDKs. So this creates a new blank PDF and then opens the two PDFs upon merging, takes the pages from the existing PDFs, adds them to the blank one, and then at the end saves it back to this. Last snippet, again, just to show that you're actually working with the actual PDF itself. This, in the browser, opens the PDF, and it runs over all the annotations. So maybe you're going to make an annotation summary, and this will be the starting point of that. So it goes through every page and looks for annotations on it and spits out the annotation type on that page. So last thing you might be wondering is JavaScript. Is JavaScript slow? Is that fast enough? How does it perform? And the answer is it performs very well compared to Canvas. We found for most documents, the vast majority is either as fast or faster. There's just a couple examples. And then compared to native speed on Chrome, we're just about there. Renders about 95% of the native speed. On Firefox and Edge, it's about 50% of native speed, which for most PDFs that don't take too long to render is perfectly good, and I don't expect most users would even notice. So, in conclusion, PDFNet.js is a complete browser-based PDF toolkit. It means that PDF apps now have the same capability of native programs. They don't need to do this dance with servers and all the sort of headaches and problems and costs those cause. They're more responsive to the end user due to the you can cut out either all or at least half the uploading and downloading that occurs for typical use cases. You reduce your server costs and scaling issues, at least for PDF reasons. It's pretty much reduced to 0 for that. And it's far simpler to develop for. It's far nicer. Developers will just be more productive and create less broken products. So at the end of the day, what this all adds up to is that it's to put PDF into web apps is now far more cost effective because your programs are more productive and you don't have to pay and deal with all these server things. And then the end product that you produce is better. It's more responsive. Users don't have to wait for so much uploading and downloading. So we'd love for you to try this out. We have a live showcase available online. If you point your computer at zoto.com, you can give it a try. And we, of course, will be here for the conference. We'd love to hear what you find and think, or if you have any questions or comments. And if you're using a mobile device, you can also find links to our mobile apps, which showcase our mobile SDKs and that technology. So here's the contact information. Thank you very much. And if you have any comments or questions or points of discussion,
Can you run it server side, say under Node.js to generate documents? I mean, in general, the things you're trying to avoid with involving a server, but data side.
could you? Yeah, I believe you probably could. I mean, we also provide native server-side SDKs, but if you already had a Node.js deployment, and for some reason you want me to, I'm not sure on Node.js, but I believe so, yes.
But you have creation elements in addition to rendering elements.
Yes.
So the implementation of this tool is totally independent of PDF.js.
Yes.
And do you guys support PDF processing in multi-thread? Like, let's say in the previous example of rendering a map, because the map is very huge.
Yeah.
Can I have one thread rendering the PDF image and the other thread doing the annotating thing in the meantime?
The annotating thing in the mean. I mean, the rendering we do in another thread. We don't, I believe, do like a bunch of different rendering in different threads. It's we look at that and it doesn't really speed it up that much. Did I understand your question?
Oh yeah, I think so. Because I don't think JavaScript doesn't really do a multi-thread.
Well, we use the web workers. That is sort of like allows you to create a second thread. So it does the rendering in a web worker, and that's in a secondary thread, and then it comes back in. And so it doesn't tie up the UI thread at all. You don't have to wait on the UI thread and come back and forth. You can let the web worker do its thing and then come back.
Oh, okay. Because those web worker you're referring to is a third-party tool.
No, it's JavaScript.
Oh, in Java. Yeah. The other certain.
So just to clarify, like all the processing happens in a background thread. So all the processing is separated from the UI thread.
Oh.
So you can do essentially multi-threaded processing. The UI is never blocked.
I see. And the other thing is, does this tool support dynamic PDF?
Dynamic PDF?
Yeah, like XFA. Have you heard about it?
XFA, no, it doesn't support XFA. It's sort of, XFA I think is, it's an interesting technology, but it's sort of on its way out. So it's not something where we're sort of concentrating on right now. Yes.
Did you have any difficulty support old version IE, like IE 8, 9, 10?
Yeah, it works
Really
best
depends
on
the JavaScript engine, right?
Yeah, it works best on the latest browsers. I'm not sure the specifics. I don't think it works on IE. I'm not sure on 9, but it's generally, especially as far as it's concerning forward-looking. It'll work on IE 11. I'm not sure about 9.
Just how does it work on mobile?
On mobile hasn't been our primary concern because we don't see, right now, most app and productivity stuff on mobile, people download an app to do that. And so we've been concentrating in that regard on our mobile SDKs. For mobile web browsers, it does work with some caveats, but the mobile web browsers aren't at the same, like, they're not as technologically progressed as the desktop ones. So if there comes a time, and it may, when people expect this sort of productivity stuff from their mobile web browser, then this will be ready. It's basically PDFNet.js should work for it. We just be waiting for these mobile web browsers to catch up technologically.
Yeah.
So you do all your own rendering, including the fonts?
Yes.
Yeah. So in smaller font sizes, do you have a problem with the fonts looking a bit uncanny? Because I know in small sizes you start to notice the difference between, say, fonts on Windows and fonts on Mac OS.
You mean like because they're so small?
Do they look slightly off from what you're used to as a native font?
And I don't think so. We do all the font rendering internally ourselves. We're not relying on the sort of browser font rendering. I have not noticed any strangeness when they're super tiny. But take a look. Maybe we can talk later. You can see something.
I know hinting is very different from Windows to the Mac.
To the Mac.
Small sizes.
So I mean, it should be on PDF. You shouldn't see that difference, right? There shouldn't be.
Well, the hints are there.
Yeah.
Yeah, we're not doing any hinting. So technically, it could be done. There's no, but we are providing consistent rendering on all platforms. So that's a nice thing about it.
Leonard?
Oh, you can have Anatole first. Then I'll go.
Just a couple of questions. First of all, how conformant is it to the standard? Like what percentage of it does it support? It's kind of a loaded question, but any information? I mean, obviously it's going to work with the samples that you show us, but I'm curious. There are a lot of PDF files out there.
Give it a try. I'd be surprised if you found one it didn't work with. There should be. It's basically the same thing as our native SDKs, which have been under development for a decade, and so we've seen, we've implemented the spec as far as we know completely. There's always, maybe some file out there that we found something, but it's a rarity now. So you should be able to depend on it, really 100%. And the thing is, because we control the rendering and everything end to end, if you were to find a problem, like there's this file that's not rendering as expected, then we can fix that and give you a version where it does work.
Okay, and I guess the second question is, there seem to be obviously two components, one being the rendering component where you already said you're creating bitmaps out of that. And then the second one was, there's obviously an interactive component that deals with the widgets and things like that. I mean, are those both of those available through your APIs?
Yes.
So since you actually said it, I'll use that. So you said it's based on the technology you guys have been developing. So is it a recompilation via ASM.js then, or is it a different approach?
It's that and more. It is compiled for some browsers currently to ASM.js. On Chrome, it's compiled to their native client. So that's how it gets extra performance, and then it's continuing to develop. Like they're working on this WebAssembly, and when that's available, then we will transition to that as well. So it's not based, like it really is the same technology as is running on the native side.
So two related. So is it a single library then, or have you broken it up into multiple?
I mean, for those.
So when I include it, am I linking against a single .js file or multiple .js files?
I believe.
So we have a single library, but basically it's an assortment of libraries. So you can choose whether you want a lean library. Like if you're just interested in viewing, then we offer a very lean version of library. And then if you want everything, then it's a much bigger library. So we have around 4 different versions.
What's the size? Just out of curiosity, what's the size of the minimum? I'll give you.
So the minimal viewer is 3.5 megabytes.
Okay.
Compressed.
Thanks.
Yep.
You've shown the viewing, which works actually very great even on complex files. Does it give access to low-level editing stuff? Can I change the PDF on cost level to?
Yeah, you have a whole COS level API, SDF objects, everything. Yes, complete low level. Low level, and then building up to, based on those ourselves, like higher level text extraction or these sorts of things.
And that could change the viewing that you're doing. So if someone selects a PDF file and I do stuff to it on low level, could that alter what is then shown to the user? Yes.
Yes. It's the PDF itself, and there's one advantage. I'm like, doesn't have to go back to the server to make these changes,
Yeah.
to re-render, and that's it.
I understand. Okay.
So get back to the model again.
Yeah.
You maybe, because you mentioned you have a simplified version scaled down for viewing. Would that be something that you might think about doing on model? The reason I'd ask is because PDFJS is kind of janky on level, and I'm not seeing that, but it's sort of experience. So we have to render raster on the server and then push it down bitmaps.
Right. The lean version of our library is more to cut out features you're not going to use for, like just with a payload that you have to download. It's not like a sort of, it's the same rendering whether or not the size of the payload is changed. For rendering it would be the same. We do have other ways of getting it that's important that show up in the web browser. We have other technology that helps for that, but it does require a bit of sort of massaging of the PDF, if you will, to make it more appropriate for mobile viewing.
You're done.
Okay, thank you.